Hello, I'm Bob Campbell with Alliance Solutions Group, and this is part three in a series on situational awareness models um, that is derived from our crisis leadership and decision making course that we developed in partnership with FEMA and have delivered to over 1,000 first responders, public safety officials, and private sector decision makers around the country. In parts one and two, we derived some lessons from the Ensley situational awareness model, looking at the perception of data, the comprehension of data, and in this module, we'll look at the projection of data and how to use that to form good decision making. So, projection. All models are wrong. You've probably heard that said. And the question is, why are models wrong? Well, let me explain a little bit of that and then transition into why we would still use models that we know are wrong and how we should use the models in decision making. The first is that these models that are out there, and I'm going to speak in context of COVID-19, a lot of them lack validity and high quality proven assumptions, such as transmission rates, impacts of social distancing, the persistence of the hazard in the environment, and things like that. They don't account for herd immunity or the immunity that's occurring, and how that may be an offsetting factor in these models, but rather they look at exponential growth based on morbidity, mortality, infection rates, transmission rates, and things like that. They also consider the population at risk as or exposed, not necessarily normalizing that based on the community model. And so that makes it a little more challenging based on the models that we end up seeing. Take a look at these different areas. The other thing that we need to consider is a lot of the factors or constants that get thrown into these models are based on experiences in other countries where there are different cultural practices that may be playing a factor in things like social distancing and infection rates, population density, and so forth. And so that's another potential cause for why they're wrong. In a lot of cases, there are just insufficient data points. So this might be, the reality of positive cases or mortality rates. That can cause a wide variation in the projection if those data points are off. And finally, the data needs to be comprehensible in order to make sense, in order to make a valid projection. And there's just a lot that we don't know as we get the data and we try to make sense of it. We're not 100% confident that in what we need to know. So there still is quite a bit of unknown out there. So a lot of this is challenging because it involves modeling and forecasting something that has not been proven or demonstrated in a laboratory environment or under controlled conditions. So there's just lots of variability. You'll remember that at the start of the crisis, the IHME model predicted 2 million deaths across America. And then more recently, those projections have come down to about 60,000 deaths. That's several orders of magnitude to be off. So that gives you some idea of how unreliable the models currently are in our situation. These models make assumptions, but those assumptions ultimately need to be compared with reality. So we might predict one thing into the future for the next 10 days, and then we compare what actually happens over those 10 days with the model, and then go back and refine the model and hopefully make it better, and hopefully make it a stronger model. So all models ultimately are wrong, but they're meant to be helpful indicators of the direction in which something is going, and there are ways to use them. I'll give you a couple examples. In our business, Alliance Solutions Group uses several different types of models. We use PLU models. We do a lot of hazardous material planning and development of emergency response plans, and we do probably thousands and thousands of hazardous material release models each year, looking at the impact on communities so that decision makers and first responders can make better decisions about how to mitigate those risks, how to inform vulnerable populations, how to plan whether they should evacuate or shelter in place if there is an incident at one of these facilities across our country. We look at mobile transit hazards and we plume model those. And then we make estimates on risk, which is all model. But it's meant to help decision makers make better decisions and place more resources where they need them based on higher risk situations. We also do evacuation modeling for natural disasters and other types of accidents. On those evacuation models tell you how long it takes to evacuate an area. Well, it's not a perfect science. There's a lot of inputs that go into it, such as the population in that area, where that population's at, the mode of transportation, whether it's daytime or nighttime, and so forth. But probably one of our more significant models is something we developed probably over a decade ago called the Casualty Planning Estimate Model. This model takes the 10 national planning scenarios, including a pandemic, but other situations like a nuclear detonation or chemical hazard, tornadoes, hurricanes, and we use historical data as well as simulated and modeled data to estimate the number of exposures, the number of cases, hospitalizations, deaths, and other outcomes from these various planning scenarios so that emergency managers across the country can use these outputs to then in turn estimate the resources. And the model does that. It tells emergency managers and hospitals how many sets of PPE they might use, or ventilators, or pharmaceuticals, depending on the situation, the staffing that they need, or how many vehicles might be needed for transport for emergencies. But we use these predominantly for planning and helping emergency managers prioritize their limited resources so that they can put them where the greatest risk is at. So we have quite a bit of experience with models and making projections. What becomes challenging, though, is when you're in the real incident and you're trying to use these models then to estimate reality. And as I mentioned earlier, one of the things that needs to be done is updating the model in the real event with real-time data and making sure that it's constantly updated and comparing the outcomes so that the model can be recalibrated closer to reality. By considering the time of, for instance, implementing stay-at-home policies, when were those enacted? How effective is the social distancing in different communities? It may be different across the country, depending on how it's being enforced or advised, or people are being educated about it. And we're constantly improving these things too. It's not like you can just pick a variable and put it into an equation, because that variable continues to change as people get better at social distancing as time goes on. So one of the things that needs to happen is those decision makers that are using models need to consider the rate of change of past models. So, for example, we started off at 2 million deaths being predicted, then it went down to 100,000, and then it got down to 60,000, and it's starting to hone in. And as the rate of change of the model, so maybe we'll call it a model of the model approach, as that rate of change continues to get smaller and smaller, we know that our model is getting better and better at predicting, and we can have higher confidence in what it's projecting into the future so that it can affect our decision making. Ultimately, projections should not be used to predict the future, but rather to compare alternatives and their relative impacts so that we can make better decisions. So the higher the quality of the projection, that should lead to a higher quality of decision making or better decisions. And as we're comparing different alternatives and we're modeling those different outcomes, then that's the rightful place for models. I hope this has been helpful, and I hope you stay tuned to some of our other videos that we'll be putting out shortly related to the COVID crisis and how to navigate these uncertain times. Thank you.